Aloha Haumana. Today we are going to be discussing and reviewing blood types. As a review, the last time we learned that there are 4 different blood types. There are 4 phenotype blood types. There are blood type A, B, AB, and O. With genotypes, AA or AI, we have B or BI, we have codominant B, and we have blood type O, which is the recessive, which means A and B are the dominant. So as a review, let's go over some of the Punnett squares that we learned the last time using Mendel's law of segregation. Okay, so we learned last time that, let's say that the blood type of a father is blood type O. This is dad. And we have a mother who is blood type A. Heterozygous. Okay, heterozygous AI. What would be the blood type of the offspring? Okay, so let's use our genotypes. So blood type O has II. So we would put II on one side. And we also put mom, who is AI, on the other side. So if we do our Punnett square according to Mendel's law of segregation, this would be AI, this would be II, and this would be II. So our genotype ratio would be 50% are going to be heterozygous AI, the other 50% would be II. And then the phenotype would be, this would be 50% blood A, and this would be 50% blood O. Okay, so that was the review on our last lesson. Today, we're going to take it a step further by adding what we call the RH factor, okay, which is the positive blood types. So in reality, there are 8 different blood types once we add in the RH factor and the RH negative factor. In this particular case, the positive is the dominant and the negative is the recessive. Okay, positives are dominant and negative is the recessive. So what that means is, anytime that there is a positive blood type, it will turn to be a positive blood type because this is positive and they're dominant. In this particular case, when you have a positive and a negative, because the positive blood type is the stronger allele, it will overpower this negative blood type. Same thing with this. If this is a positive blood type times this blood, because positive is stronger than the negative, it will remain a positive blood type. The only time you will have a negative blood type is that both alleles are going to be recessive. And so in this particular case, this would be a negative blood type. So the genotype of this particular would be that 3/4 of the child will have RH positive and 1/4 of the child would be RH negative blood type. Okay, that would be that. And the phenotype would be similar. RH positive blood and 1/4 will be negative blood. Okay. Okay, that's very important to know that positive is dominant and negative is recessive. Okay, so now let's apply this to what we learned the last time. Now let's put in the different blood types. So now once we put in the RH factor, we now have 8 different blood types. So we now have blood type A, B, AB, and O, but in reality, there are now A positive, we have A negative, we have B positive, B negative, AB positive, AB negative, O positive, and O negative. But the genotypes remain the same. The only thing we're going to be adding now is the plus plus, okay? AI, etc. Okay, this is going to start to make sense once we do some examples. Okay. Okay, so, and then give or take plus or minus for each, plus or minus, plus or minus. Okay, so here's example number 1 now, adding the RH factor. This will pertain to the worksheet that you will be doing on page 3. Okay, so for example, let's say you have this time a dad who is blood O positive, and you have a mom who is AB positive. What will be the blood type of the offspring? Okay, in this particular case, the blood type for O would be I plus, I heterozygous negative, and we have this one will be A positive and B positive. Okay, what will happen to the blood types? So let's put these alleles here. Okay, so that's I positive, I negative, we have A positive and B positive. Okay, so now same thing, the A and the I go together, and because positive is dominant, this will become positive. Okay, same thing with this, AI, because the positive is stronger than the negative, this will remain a positive blood type. Okay, this would be a BI positive blood type, and this, because again the positive is stronger than the negative, this will still become a positive blood type. So the genotype now would be 50% AI positive, and you have 50% that is BI positive. So in the phenotype, this would now be blood A positive, and this would be now blood B positive. Okay, as the example. Okay, I'm just gonna go to that. So that's adding the RH factor. Okay, let's do another one. So let's say this time we have mom who is A negative, so that would be A minus, I minus, and we have a dad who is also a B positive but heterozygous. Okay, what would the outcome of the cross will be? Okay, so we put these alleles and these alleles. This is dad. Okay, so AI minus, I minus for blood type A negative. Both have to be negative to be negative. This one is actually a blood AB positive still, but even though they're heterozygous. Okay, so now let's do the Punnett. This becomes homozygous dominant. But again, because the positive is stronger than the negative, this will say positive. Same thing with this one. It becomes AI positive. And then this one becomes AB negative because they are recessive. Only two negatives make a negative. And this becomes BI minus. Okay, so now the genotype ratio would be 25% would be AA positive, 25% would be AI positive, 25% would be AB negative, and 25% would be BI negative. But the phenotype would be a little different. Since these two are the same, 50% of them are going to be blood A positive. But this guy is different. 25% would be AB blood negative, and this guy is 25% B negative blood. Okay, so that's how you do the Punnett squares. Okay, the last thing I want to go over is what happens when they ask you to find the baby daddy. So these are now problems number 3. Okay, let's just, okay. This time, your task is to figure out who is the father. So these constitutes to problems number 5. It's like the number 5 on your worksheet. Who's the baby daddy? Okay, 5, 4, and 5. So this time they give you the mom, who is, let's say her blood type is O positive, to be more, be A plus, I plus minus. And you have a child who is B negative. Okay, to be more precisely, B, so there's going to be 2 B's, or BI. We don't know what kind of B negative this is. So we're going to have to figure out the Punnett squares. And there's going to be 2. Okay, because child could be either this or this. Okay, so what we're trying to do is, who is the dad? We do know mom. So mom is I positive, I minus, I positive, I minus. And the child, because this is the child, that means this is, could be the possible blood type for them. Oh, this is not possible. Sorry, that is not possible because we have a blood O. So that means we only have a B I minus, B I minus. Okay, so this cannot work here as well because positive will make a positive. So now we're going to use Mendel's law of segregation, which states that one allele must come from mom, so this B must have come from dad. Okay, in order to be negative, dad must also be a negative. Okay, so that's one possible allele for dad. So dad could be a B minus because of that. Yeah, it can only be a minus. Okay, so dad, that's one possibility. What's another possibility to getting a BI negative child? Okay, so another possibility could be AB negative. How do we know? Because when you do the Punnett square, this gives you AI, this gives you BI plus, but this gives you AI minus, and this gives you BI minus. Okay, so that's another possibility. So when asking what are the possible blood types of dad, there are 2 possibilities. He could be a blood B negative, because in order for that to work, the child must match that, and that matches here, and that could also be a blood AB negative. Okay, and that's how you do the more difficult Punnett squares, and you can then now eliminate suspects in that, because if the child doesn't match the blood type of the Punnett square in here, that means that's not the correct dad. Okay, and that constitutes to number 5. When you have to figure out who's the baby daddy, is there Kobe Bryant, is it LeBron James, or is it Stephen Curry? Okay, hope this video works for you, and let me know if you have any questions.